finding and fixing performance bottlenecks in real-world Liferay applications. My name is Andreas, and this is Boris.
Hello.
In the last year, we had 2 projects that had performance issues. And the one was an in-house application that we built ourselves. And you can find the specs here. It's an application with not so many users. But after the 3rd sprint that we developed, we faced serious issues with performance. And what we did, we followed the approach that I learned yesterday morning in the habits of good programmers, which is make it work, make it right, and make it fast. And after that sprint, it was working, but it was not fast. And the trouble was that they had an old application that they wanted to replace with that one. And this was even slower. So yeah, we had some management attention there. So the other application with performance issues was something that we didn't build ourselves. And it's an application, a public application, where students can apply for a scholarship. And so 2 times per year, you have a very high load on that platform, and the database grows during that time about 10 gigabytes, because the students upload their applications there. And during the peak times, they ran into serious load times. They had 15 minutes or timeouts, so that was really nothing you could work with. Now, the good news is we could fix both, and both response times are now very fast. So let's talk about how we did this. Now, the first question is, we are talking mostly about enterprise applications, and they used to be slow and ugly and expensive probably as well. So what has changed that they now have to be fast? Well, of course, a lot of the applications move to the web now. And with Liferay applications, of course, they are web-based. And users are just used to have interactive graphics or snappy user interfaces and a great user experience. So that's what they're expecting from their enterprise applications as well. And this is really nothing backend developers or Java developers are usually trained for. So Liferay helps us in that regard. But we're talking about complex individual solutions, so that only helps a bit. So maybe you wonder, is my project at risk? So here's a short guideline. First of all, the project, does it have a very ambitious timeline? Does the customer expect fast turnarounds? And probably a lot of projects have this. And our project had this as well. So yes, we had this risk. And the next one is the solution a highly complex one, not only in technical, but also from a business point of view. From a business point of view, you have to develop new things that the customer has never seen before. And from a technical view, you probably need solutions that your team hasn't built before. So both things applied to our project. So yes, definitely we had a risk there. Now, when you look at the team that you're building this solution with, usually you do not only have experts on the team who have done this a couple of times, but you also have beginners that are new to the solution. And maybe you also don't have database experts who have a clear sight on what happens on the database. So yes, we had that as well. We had beginners on the team, but we were fortunate to also have database experts and computer experts on that team. Another thing is data. When you develop, it's usually hard to get real data because that data usually just occurs after the application went live. So we were in the lucky position in both projects to have the actual data for this. So we didn't see a risk there because the databases were basically the same and they had the same size. The other thing is, when developing, the question is if you have a dedicated stakeholder for performance topics on your team who is just taking care of performance. And we didn't have that either, so another reason to see the risks now. Okay, there are 2 places when you can optimize. You can optimize in development, and you can optimize in production. And usually you try to make the product or the solution you're building work. So your focus during development is probably not performance. And when you ask your developers, or that what they tell me sometimes is that the hardware in development is much slower, so the results of the performance tests really are not comparable to what you will see in production. And in production we have great hardware and everything will run smooth there. Yes. On the other hand, to optimize in production is a lot harder because you have very high visibility, and it's really slow to do changes there because of all the complex management issues. And here's an example of production that went wrong, and this is the feeling that your customers have. Maybe the developers sometimes don't feel it, but the customer saw his satellite, which was on top of this Falcon rocket, explode, and so he was very scared, and this is the feeling that the customers have. So yes, I hope they will be launching soon again. Okay, so how do you do development optimization? Basically, it's a well-known checklist, and you can ask your developers what to optimize. This is using Suttons Law. And Sutton was a bank robber, and a reporter once asked him, "Why did you rob the bank?" And Sutton said, "Because that's where the money is." So they know where they can optimize. And you can look at those things like configuration. Are all your development modes disabled? We found that not only Liferay has development modes, but also prime phases, and there may be other libraries you're using that have development modes. Also, something you might not require during development, but surely in production, is using the Liferay caching. And in the Liferay Connected Services, you can actually check the usage of that cache, and you should do that. Next, what we did is we added a web server, because it's a standard procedure for this, to move all the static content from the Liferay server to the web server and reduce load. But what we also did is, in that one application, we had financial data that was displayed as a graph. And during development, this was built or created on demand. And then we changed that to a pre-rendering after the data is loaded. And we put all those images on the web server so that this load is also taken from the Liferay, which also improved performance a lot. And of course, you have to look at the database, and we'll get to the database a little bit later again. Maybe you can, to keep data on the database, add database procedures or add specialized views and indices. So the other application we were talking about is the student application, and our experts panel said it's of course slow because it's the 6.1 community edition, so we switched to 6.2 enterprise edition, and we saw a lot of standard Liferay functionality that was not used for permission management, and we replaced this with this Liferay standards. But it was still slow, and so we had to work on that. And here's a cycle that we used to optimize the performance, maybe as a guideline on how to do this. First of all, you should, of course, measure, have a baseline measurement before you do any changes, because that gives you something you can show to the customer or to your boss. We improved the performance from this to this and this. Then you will run the analysis, and we'll get into this in a couple of moments. And you will uncover probably a lot of issues that you can fix. But you should only fix one issue and document the change so that later on you can see which changes were actually helpful. Okay, with this, Boris, here is your talk.
Thank you very much, Andreas. There are plenty of tools that you can use in order to measure performance. The ones that we used can be categorized into development best practices tools that you would normally use to measure performance on smaller scale, like the speed of execution of a method or very on granular level. Then there are basic tools that you can get around with during the QA phase. There are profiling tools, and there are system monitoring tools that you would preferably use when you scale up your tests and see how your JVM performs on a under larger load and with a more concurrent users. So in order to get a grip on this performance of single methods performance, we extended our logging framework. We used Spring JPA Spring AOP in our application, and we could achieve actually those changes, so this logging extension, with very little additional code. Basically, we defined events where we started a stopwatch on the start of method execution and stopped the stopwatch when the method execution was over. And then we initialized a logging event where we put into the logs the execution speed of a method, so execution time, and also the method signature and the parameters that were passed. And especially we could target in this way certain areas like the repositories. Like in the present case, we mostly address the database access issue, but I will get to this later. It also made possible to define our own annotations, to annotate our custom methods, also to expose them to those extended logging framework. Everybody uses browser nowadays, of course, but many developers are not aware of the cool features that are actually hidden inside the browsers, like here in Chrome. By the way, it's supposed to be the fastest browser. There are very cool features out there, so you can really hit that F12 button and see what it offers. You can do plenty of stuff. You can see how long an SSL handshake took. You can see all of those HTTP errors that appear there, maybe. You can see the size of your JavaScript and CSS files and image files. And yeah, this is very important. I heard a story of the FIFA.com webpage where they had a favicon file that was 370 kilobytes large. The favicon is a small symbol that appears near the browser, so you want to avoid those cases. It also has some cool features like imitating a slow connection, like how fast would your page load if you do this on a 3G connection, for example. In our case, we saw that our bottlenecks were not on the front end, but mostly on the back end. So we saw that the most time is spent on the server. And then we dig a little bit deeper. In order to create the baseline for our performance tests, we used the pretty much standard and widely known JMeter tool. And it's very fast to create and very easy to create performance tests within JMeter. You actually only need half an hour for this. You configure a proxy within your browser, you perform some user actions, and there the test will be recorded. But it really makes sense to invest some more time and effort into those tests to make them more repeatable. So if you run them twice, they should get you more or less the same results. They should be reliable, so really look at that HTTP response you're getting. It should match the things you see in the browser if you perform the test manually. So input some of those checks or probes within your tests that the response is really the one you're expecting. And also make the test realistic. Only a user with some special superpowers could click 10 links in 1 second, like JMeter does. So really input some of the timeouts, some of the pauses between user interactions, and also use browser caching, so imitate a user's behavior with them. On the graph you see the results that you would get, that we actually got in our application, which was not very great, but we needed this to create the baseline to start from. Then we did some profiling. We did this with a tool, JProfiler, and this is where we collected the most low-hanging fruits during our performance analysis. And this is very cool because it was a really fun job because you can do it interactively. So you perform some actions on your application, and at the same time you see what is the impact on the CPU, what is the memory footprint, what are the database queries that are executed, and how many queries are executed at the same time. And especially this database access area was the one that was very cool, where we collected a lot of stuff. Like in this example, we saw that a count was performed on a database, and it took almost 1.4 seconds to execute. So we digged a little bit deeper into that, where it came from. It came from a method addressing a JPA repository. A count statement was executed by this. The only thing the developer probably didn't think about is that this repository is mapped to a database table that contains more than 1 million entries. So a count will take, of course, a lot of time. And in general, it makes sense to really look at the database issues, because the problem is that developers nowadays don't want to do that much with SQL, actually. And they tend to have an abstract view, actually, on the database access. So sometimes it's not clear what are the statements that are executed by your code. Some people kind of lose this understanding. And we fixed it by introducing materialized views in our database, and we reduced the time to 1 millisecond. So during our profiling operations, we removed some long-running, non-optimized SQL queries. There were lots of them. We uncovered some bugs in caching and also in configuration, like the database pooling was not set correctly. We could also see this from the profiling. And we also found some architectural improvements that we could make, like, for example, you don't always need to load all of the data. Some of the data could be loaded on demand, actually, when user performs a certain action. So you see this stuff also during profiling very well. And after those bigger problems were eliminated, we scaled up our tests. We performed them with a large amount of users over a longer period of time, and we looked on how our GVM was performing. We did it with the Java Visual VM, or we also created some garbage collection logs and created their online resources when you create graphs out of those JC logs, which is pretty comfortable. And in case of our students app, we saw that and all the time some amount of heap was occupied after each garbage collection. For those of you who worked on performance issues before, this is a typical image of a memory leak. We performed a heap dump, and we inputted in the Eclipse memory analyzer, which is also part of your Liferay Developer Studio. And we saw that there was a class whose instances were occupying 2 gigabytes of heap. And yeah, by Googling it, we found a Jira ticket for our version of JBoss application server. So it was a pretty interesting thing. Maybe application server bug would not be the first place to look at, but it shows really the importance of executing those tests over a longer period of time, because you can see those things only by this. So what is the best GVM configuration for my portal? In my opinion, this issue is a little bit overrated when I hear about Liferay performance. People talk a lot of setting different flags and what is the best flag for me. And I think actually all the time that, yeah, there are tons of other places where we can make a mistake, or we are not working on Java standalone apps where this could be the main issue probably, but we're working in a very distributed environment with complex frameworks, with database access. So I would say the JVM configuration may be the last place actually to look at. But nevertheless, we still checked a couple of different parameters, and we actually managed to do this in an automated way. So we wrote a script that shut down our Liferay, performed one configuration change, then started Liferay, and automatically performed JMeter tests. And then it did it again for the next configuration that we did. So in this way, we could perform dozens of different tests overnight, and in the morning, you get to work and you see, this is a list of all the tests that were executed. This exact configuration would be the best for me. So we still did it. Yeah, on the example of JVM configuration, you also understand sometimes that copy-paste is really not a very good idea if it comes to configuration changes. Or actually at some point, somebody took the parameters that were suggested by the deployment checklist, and those were actually not the best for us. So we actually managed to have a 5% performance gain by removing those parameters that we got there. So sometimes really not the best idea to copy-paste. Yeah, what did we learn?
So what did we learn? First of all, performance is not a risk, it's a certainty. And we should consider this all in our projects. First of all, even starting in the design phase, think of the issues that could arise, the things that could be slow. So maybe you can, by adding a different user interface, make it better for the user. And always plan a performance optimization phase.
Yeah, the Java developers seem to overlook the database access issues. So I would say create awareness in your team for the SQL queries the code of your developers executes. And also work with the data that is fresh and actually production-like as possible. And
always keep an eye on performance issues. Monitor it early and regularly using the process described in development and production, and have a dedicated owner for this. And with that, thank you, and may all your apps be fast.
Are there any questions for Andreas and Boris before we move into the next section? Yes.
Hi, I do also performance analysis. I don't have a question, I would just add 3 points. One is how to find the bottleneck without restarting the server. You can simply, maybe differently. You had a lot of time to change the source code and do analysis, but you can use tools like, for example, Xrebel that gives you immediately the results in the front end, the bottlenecks in the back end, but everything is shown in the front end. Another thing is Groovy scripts. You can run the code that is making problems in the control panel, and you can very quickly identify the problem. And last thing, run crawler on your whole portal, because sooner or later somebody created a page that might be a problem for the CPU or memory.
Yeah.
Thanks.
I think that what we had here were really individual applications, so we were not focusing so much on Liferay issues, but issues in a Liferay environment. So thank you.
Any more questions for Andreas and Boris? Okay, with that then, let's have one last round of applause for Andreas and Boris. Thank you.